In this video, we'll be solving systems of equations using substitution. The first example is to solve the system 4x minus 3y equal 14 and x minus 2y equal 1. We'll be solving using substitution. So our first step is to solve one of the equations for either x or y. If we chose to solve for x in this equation, we would have to eventually divide by 4 to get x by itself. This would lead to fractions. It's doable, but we can take an easier route if we solve for our x using this equation, since the coefficient of x in this equation is 1. So if that happens in your system, then it's usually best to solve for that variable. So if we take x minus 2y equal 1 and solve for x, we'll do that by adding 2y to both sides. These cancel, and we get x is equal to 1 plus 2y. You can't actually add these two because they're not like terms. Then our next step is to substitute this expression into the other equation and solve. So since we solved the second equation for x, we're going to substitute this expression in for x into the other equation. So we're going to put it into this first equation. So we now have 4 times 1 plus 2y, and then continue writing this equation. So minus 3y equals 14. Now you'll notice that the only variable that we have in this equation is y, so we can just solve this one. The first step, I'm going to distribute my 4 through the parentheses. So 4 times 1 is 4. 4 times 2y is 8y. And then copy these other terms. We'll combine like terms here. 8y minus 3y is 5y. And I have this 4 here. I need to get that off of the left side and onto the right side. So I'll subtract 4 from both sides, which will cancel that off. So now I just have 5y equals, and then 14 minus 4 is 10. To get y by itself, I need to divide both sides by 5. And y is equal to 10 divided by 5, which is 2. Now that I know the value for y, I can put that back into this equation. I have x is equal to 1 plus 2 times, and then in place of y, I'm going to put my value 2. So x is equal to 1 plus 2 times 2 is 4. So x is equal to 5. So the point where these two lines intersect is the point 5, 2. By the way, this system is consistent because there is a solution and the equations are independent. Because you can't get one of the equations by manipulating the other one. All right, let's do another example. All right, in this example, we're going to solve the system using substitution. Our first step, again, for substitution is to solve one of the equations for either x or y. Now, you'll notice on this system, all of the terms have a numerical coefficient other than 1. So it's really left up to you what you'd like to solve for. I personally prefer to divide by 2 instead of 3, so I'm going to take my first equation and I'm going to solve it for x. So let's just write the first equation. Subtract 3y from both sides. So now I have 2x equals -1 minus 3y. And then I need x by itself. So I'm going to divide every term by 2. And I have x is equal to a -1/2 minus 3/2 y. Now, since I solved the first equation for x, I need to substitute into the second equation. So my second equation is 3x minus 2y equals 18. I'm going to take this expression, since it's equal to x, and I'm going to substitute it in right here. So you're going to take the x out and sub in what it's equal to. So I have 3 times the quantity, -1/2 minus 3/2 y, and then continue writing the rest of the equation. Minus 2y equals 18. And let's distribute our 3. 3 times -1/2 is -3/2. 3 times -3/2 y is a -9/2 y. And then copy the rest of my equation. Let's add 3/2 to both sides. These will cancel. And I have a -9/2 y minus 2y equals, see, 3/2 is the same as 1/2. So this, when I add these together, will be 19/2. To get a common denominator here, I need to multiply top and bottom by 2. Or you can just do this math on your calculator. I prefer to do it by hand. -9/2 and a -4/2 is a -13/2 equals, this is 39/2. And then to get y by itself, I need to multiply by the reciprocal. So a -2/13 on both sides. Or you could just divide both sides by a -13/2 if you have a calculator available. Multiplying by the reciprocal, these cancel, and I have y equals, the 2's cancel here, and I have 13 divides 39 3 times. So looks like I finally have a -3 for my y value. Alright, then I can put that into this equation to find my x. So my x is going to equal a -1/2 minus 3/2 times -3. So -1/2. -3/2 times -3 is a positive 9/2. So x is equal to positive 9 halves, subtract 1 half will give me 8 halves, which is 4. So my point where these two lines intersect is the point for -3. Since there is a solution, the system is consistent and the equations are independent.